Okay, let me get a light on the subject here. And we're going to be changing decimals to fractions. And we've got what's called terminating decimals and repeating decimals, and the way you handle them are different. So let's start with the easier ones, the terminating decimals. We're going to determine the place value of the last digit, and if the place value is, for example, tenths, you're going to put the decimal digits over a 10. So here's our example. We have 0.5 as our decimal, and that's in the tenths place. So I take my digit 5 over 10 as your denominator. And then once you've got it set up, then you can reduce the fraction if necessary. And in this case, you really should reduce it. And so whatever you do to the numerator, you must do to the denominator. We will divide that by 5 and divide the denominator by 5. 5 divided by 5 becomes 1, and 10 divided by 5 becomes 2. So really, 0.5 is equal to 1/2 in fractions. If it is what's called a mixed whole number with a decimal, such as 7.3, it's whole number and decimal, we're going to separate the two. This is one way you can do it. And so you can say the whole number 7 plus 0.3. Then change the decimal to a fraction, and then add them back together for the final answer. So that's another way of handling something that's a little more complicated, like 7.3. It's separated to 7 plus 0.3, so then we're going to take that 0.3 and put it over its place value, which is tenths, which is 10, and that can't be reduced, so that would just be added to the whole number 7. 7 and 3/10. Okay, and that would be your final answer, 7 and 3/10, since it can't be reduced. All right, now what about those repeaters or repeating decimals like 0.6? Well, and here's another example, 0.45. You first take a look at its place value. This one's in tenths. This one's in hundredths. On this video, I'm only going to show you the shortcut for this. There is an algebraic explanation for it, and we did go over that in class. We went through our Common Core workbook that demonstrated how to understand this. And if you really want to see the reasoning behind it, please refer back to your Common Core workbook and look at the example. I'm just going to show you, once you understand it, the shortcut. Okay, so the denominator becomes the place value minus 1 for a repeater. So here's how it works. 0.6 repeating equals 6 over its place value, which is tenths, so 10 minus 1. So it ends up being 6 divided by 9. Now, you can reduce this fraction by dividing each numerator and denominator by 3, and we end up with 6 divided by 3 is 2, 9 divided by 3 is 3. And one thing you can do is check your answer to make sure you end up with the original value, and the way you check your answer is take your answer, turn it back into a division problem, 2 divided by 3, get your decimal in there. Can 3 go into 2? No, so put a 0. Put your add in zeros. Can 3 go into 20? Yeah, 3 can go into 20. How many times? It can go in 6 times. 6 times 3 is 18. I get a 2 remainder, bring down my 0, and you can already see this is going to repeat like the answer you started with. So that's how you check your answer. Okay, let's look at another one for the shortcut method. We have 0.45 repeating. Okay, so our rule is look at your place value of the last digit. That's hundredths. So you take the 100 minus 1 for your denominator. That'll end up being 99. And take your decimal, 0.45, put that over this 100 minus 1. So it's 45 divided by 99. And can that be reduced? Well, let me remind you of your divisibility rule. The divisibility rule for both 3 and 9 asks you to add up the digits of a number. So that would be like 4 plus 5 equals 9. And can 3 go into 9? Yes. So this is divisible by 3. Can 9 go into 9? Yes. So it's divisible by 9. Of course, when you reduce, you always want to choose the highest number that can divide into it. So I'm going to choose the 9. And it's obvious that 9 will go into 99. So 45 divided by 9 is 5. And 99 divided by 9 is 11. And again, if you want to make sure you did it right, you can also at this point check your answer with a calculator. 5 divided by 11, and I think you will find out that you will end up with this repeating decimal on your calculator. Okay, and I always say it's a really good idea to double check your work by taking the time to do that division at the end. And like I say, just do it with a calculator. Okay, thank you.